Welcome to the Spintangle. This is the lecture 2 of Ising model, that is the lecture 19 of our statistical mechanics series, in which we will be discussing a very special problem. By this problem, we will understand about the Ising spin and the type of the problems that could be asked in various examinations. Okay, so let's move on to the problem. I am writing the problem first. Let you have three Ising spins and each can take values plus minus 1. Find out the partition function. For the combination as shown. Okay. Here is a extra note is given, that is the interaction parameter is same for each pair. Okay, this is the question. So this is the configuration that has been given, and read the question carefully first. Okay, read the question carefully. That let you have three Ising spins. Okay, these are I am writing this I in capital format because this is Robert Ising. Okay, Ising spins and each can take values plus minus 1. That means you have some Ising spins, that this is a Ising spin, this is another spin, this is another spin. Okay, find out the partition function for the combination as shown. Okay, partition function, and the interaction parameter is same for each pair. This means the interaction parameter could be taken as some value. Okay, some value. So let's start from the beginning. Okay, so in step 1, what we have to do? Step 1, in the previous lecture we have seen, first of all we need to construct the Hamiltonian of the system. The Hamiltonian is given by H equals to minus Jij sigma I sigma j minus the magnetic field times say it is sigma j. Here it is upon j, it is I comma j. Okay, there are three spins, so I can write this thing as, for the 1-2 combination, 1-2 sigma 1 sigma 2 combination, I am writing this as j 1-2 sigma 1 sigma 2. Here is a minus sign which is arbitrary. Okay, for the 2-3 combination, say this combination, for the 2-3 combination there will be minus j 2-3 sigma 2 sigma 3 minus j 3-1 sigma 3 sigma 1 minus b, here it is a, and you have to extend this sigma j into its components, sigma 1 sigma 2, the spins. Okay, not components, the spins. This is the value of sigma. So it is given that the interaction parameter is same for each pair, therefore we can take, say, j12 equals to j23 equals to j31 equals to, take some value, say it is j. Okay, now let's move on to this. So Hamiltonian will be what? I am putting j here, putting j here, and putting j here. That will be j. So it is take j common from each of the term. There will be sigma 1, sigma 2 plus sigma 2, sigma 3 plus sigma 3, sigma 1 minus b. Here it is sigma 1, sigma 2, sigma 3. Okay, this is the Hamiltonian and you have to work for it. Okay, this is the Hamiltonian. Now what you have to make? You have to make a table. What is our table? That is spin. The possible spins are given in the question. That is, the possible spin are what? Each can take values plus and minus 1. That means sigma 1 can take values, say sigma 1 can take values plus 1 and minus 1. Similarly, sigma 2 also can take value plus 1 and minus 1, and the similar way sigma 3 can take value plus 1 and minus 1. So these are the combinations. Now make the table. Okay, what is our table? Before making table, make sure this is the Hamiltonian is visible to you. Okay, otherwise you cannot construct this thing. Okay, the Hamiltonian, let me take this Hamiltonian. Okay, so the table will be what? The table will be of spins, the possible spins, say it is sigma 1, sigma 2 and sigma 3, and for this possible combination there will be energy. Okay, calculating the Hamiltonian value. Okay, the energy, you can writing the energy. Now for say for I'm taking, there are values plus 1 plus 1 plus 1 value of each of the term. Therefore what will become? Put plus 1 here, plus 1 here, plus 1 plus 1 plus 1 plus 1. Therefore this will be a minus 3j, and here also plus 1 plus 1 plus 1. Okay, therefore what does it become? Minus 3b. This is one combination, and if you have to make, I think, how much number? 3 times 3, that means 9 possible ways will be, I think there is. Therefore now I am taking sigma 1 value as plus 1, 2 value as plus 1, and the 3 value as minus 1. Now check this thing. This will be plus 1 times plus 1. There will be a negative 1 term, there will also be a negative 1 term, and the first term and second term will goes with each other. There will be a plus j term. You can check it by one. Okay, so now putting here also plus 1 plus 1 minus 1. There will be what? There will be minus b term. Okay, j minus v. And in the same way you can put plus 1, and in the second term it is minus 1 and plus 1 also. So 1 minus 1, if there is 1 minus 1, you can check this thing. What is the value? 1 minus 1 plus 1, 1 minus 1 minus 1, sorry, 1 minus 1 minus 1, that means j, and here it is a minus b, j minus b plus j minus b. And now you were supposed to put take the sigma 1 as minus 1, sigma 2 is plus 1, here it is a plus 1. Okay, and the same value will appear, j minus b. Now I am moving to two minuses. Okay, say 2 minus, minus 1 minus 1, this is plus 1. There are two minus terms. Okay, now I am taking this combination. First let me write the combinations first. Minus 1 minus 1 plus 1, here will be a minus 1 plus 1 minus 1, here will be a plus 1 minus 1 minus 1 term. Okay, so calculate now how many terms are there. 1 2 3 4 terms. Now 2 terms remaining, I think so. 4, there will be, I think there will be 8 terms. Okay, there is no other combination. Minus 1 minus 1 and minus 1 I am taking. Now calculating the energy for this thing, the energy will be what? Put this thing here, this thing for energy. Let me mark this. Okay, let me mark this. 2 minuses. Okay, therefore here will be a 2 minuses, therefore this term will be minus, this term will be minus, this term will be plus, therefore j plus j minus minus plus, this means minus 1 minus 1 minus 2 minus 1, there will be j plus b term. Okay, that means 2 minus gives that plus j plus b, and this will also be same. This is nothing but intuition. Okay, you can make intuition. Okay, and in the last term you can check this thing. What will be the last term? Minus 1 minus 1 minus 1 combination of what will give this? Say minus 1, this will become plus, minus 1, this will become plus, and this will become plus, therefore minus 3j, and the minus 1 minus 1 minus 1, that means this is I think plus 3b. Okay, minus 3j plus 3b, these are the combinations. Okay, now I have got the energies, I have got respective energies. Okay, now this was the first table, say table 1, in which spin versus energy table. Okay, and in the table 2 I'm going to the next table, say table 2. This is what? Energy versus degeneracy. Energy versus degeneracy, that means what are the degeneracies? Okay, make table of, say there are EI and here are GI is EI. How many values, how many possible values of energy are there? Say minus 3j minus 3b. Is there any minus 3j minus 3b? Not. This is minus 3j plus 3b. This is not similar. Therefore, how many? Minus 3j minus 3b. This is non-degenerate. That means degeneracy 1. And now I am also taking this thing as in the next. Say minus 3j plus 3b. How many terms? There are one microstate, one degeneracy, one non-degenerate, and there are energy levels. Energy levels are what? Minus plus j minus b. How many plus j minus b here? Plus j minus b plus j minus b. There are 3 plus j minus b. Okay, therefore threefold degeneracy. Plus j minus b is 3, and also there are plus j plus b. I think you could check it from the table. Okay, there are, check it from the table. This term are 3, this similar terms, similar energy. Okay, so therefore this also have threefold degeneracy. Now you have got the energy versus degeneracy tabulation. Okay, energy versus degeneracy tabulation. So write down the partition function. What is our partition function here? Our partition function is, say our partition function is PF, writing this PF. Okay, not PF, you can write this thing PF. Okay, partition function will be what? We know what is partition function, that is GI summation GI over I e to the power minus beta EI. Therefore expanding this up to, there are four terms. Okay, there are 4 terms, 1 2 3 4. Say this is what? This is G1, this is G2, this is G3, this is G4, and this is E1, this is E2, this is E3, and this is E4. So expanding this, G1 e to the power minus beta E1 plus G2 e to the power minus beta E2 plus G3 e to the power minus beta E3 and G4 e to the power minus beta E4. So put these values. What is our G1? G1 is 1. E to the power, I am not writing 1 here. Okay, this is 1. Right, just write e to the power minus beta is here. E1 is what? E1 is minus 3j I think it is minus 3b. This term is gone. Okay, now this term, moving on to this term, this 1 e to the power minus beta. Say what is our next term? Minus 3j plus 3b. And then in this term, what is our g3? It is 3 plus 3 e to the power minus beta plus j minus b, and here also a 3 e to the power minus beta minus j. There, I think there is a minus, not minus j plus b. Okay, this is your partition function. These are minus. This is your required partition function. Okay, that's it. This is the required partition function. In this way you can calculate the partition function. I will be giving homework for you on WhatsApp or Telegram group. Okay, so join WhatsApp or Telegram group. Okay, this is the expression for partition function, where beta is what? Beta is equals to 1 upon kt. Okay, beta equals to 1 upon kt. So thank you for being with us. Like the video and subscribe the channel and share among your friends. Thank you.